Welcome to the PLM 4.0 show with me, Andrew Sparrow.
And me, Bryan Spellman. Today, we get back to the fast-growing world of model-based systems engineering.
So what do we actually need MBSE? So the purpose for model-based systems engineering was to move away from being document-centric. MBSE is much, much more than that. It's not just a buzzword. It's an important application that allows us to develop, analyze, and to test complex systems.
We need MBSE because it provides a means to coordinate system design activity, satisfy stakeholder requirements, and it provides a significant return on investment. The model-based technique is really only as good as the MBSE tool you use, so it's important to choose the right one.
And today, to help with that education and to help with that selection, we're looking at a relative newcomer, at least to us, to our systems engineering world. But before we go there, let's introduce you to our special guest, Yves GÉNEVAUX.
Yves is a graduate engineer from École des Arts et Métiers. Hopefully I got that right. He'll tell me if it did.
That's pretty good. That was impressive.
He has worked in the field of system and software engineering for embedded systems for more than 25 years. He collaborated with key accounts of the aeronautical, railways, automotive, energy, telecommunications, and defense industries worldwide. After several years of working as a software engineer, Yves developed several startups offering development and validation tools for embedded systems. We had Verilog, Polyspace Technologies, and ArgoSim. He also worked for large US-based companies such as MathWorks.
So everyone, please, you'll see a section to your left, maybe even below, that says put in your comments, put in your questions. Please go right ahead. Feel free to interrupt as we go. Welcome them all. So let's get the show on the road. Ready, set, go. Welcome, Yves. How are you, sir?
I'm doing all right. Just in Italy right now, so enjoying myself, of course.
In beautiful Italy. Where are you in Italy?
So in the northern part of Italy, I'm spending a few days working with a very prestigious car maker I cannot name.
Okay. I think I can guess. Fast cars, hey? Sounds good. Good luck with that. Anyway, great to have you on this show.
Thank you.
Before we dive in too much with Yves, we do want to mention that coming up on October 11th and 12th, we've got the MBSE Cyber Experience Symposium in Gothenburg. So you can join XDI and DS at the annual European Conference of CATIA No Magic for networking, for interaction with MBSE, PLM, PLE, systems engineering, and enterprise architecture industry experts. Again, we have another keyword soup here, but we got that for all these experts all in one place.
Yep.
This 2-day conference is training on day 1 and then conference on day 2.
And I know, Yves, you're going to be at that conference. What are your plans there? What are you going to be talking about? What's your hopes for the show?
I'll be sharing some information as I'm going to do with you guys today, but also I'll be really enjoying this kind of event because around CATIA Magic, around our MBSE offering, there's a lot of really passionate people. It's really extremely interesting, enriching, and really pleasant to be there.
Got it. I know it's the first ever MBSE symposium in Sweden. It could well be in the Nordics. It could even be Europe. I don't know. But so anyone, if you're in the neighborhood, you're around, please get down there. You see Yves in full flight, as well as some of our guys as well. So it'll be a pleasure. Have fun there.
Yeah, you'll find XDI and DS in the conference hall. You can come over and say hi to another guest we've had on the show before. So Håkan Theobald, who's leading the way, as those who watch will know, across the Nordics. And then we have Sean Chadwick, our VP for Euro North, and Mark Karamunugian, who's going to, he's our discrete manufacturing process lead. So lots of cool stuff happening. Make sure to come by and say hi.
Sounds good. So let's get going into the main event. We're going to be talking end-to-end MBSE, the new paradigm. So for critical systems, either standards mandate that functional specs are based on texture requirements, or the latter are part of the contractual agreements. Therefore, it's imperative that what we write is what we mean, with no ambiguities, omissions, or errors.
The requirements management tools bring traceability and versioning capabilities. MBSE tools help capture the architecture and use cases of complex systems. But despite all of this, most errors are introduced during the specification phase when writing the requirements, and most of those errors are not really found until as late as the testing phases.
You got it. You got it. So, Yves, let's get the show on the road. Please kick us off with your thoughts and your few slides to walk us through some of the challenges and how we overcome them.
And thank you for giving me this opportunity. Indeed, what I call end-to-end MBSE is reflecting the innovation we have brought with Stimulus some years ago, and the fact that MBSE as a term is often used as a synonym to SysML, and of course it goes far beyond that. And in particular, the use of models can be actually extended to what it was not covering, or what SysML is not covering, which is the functional requirements, which are usually written with plain text and then resist to verification capabilities of the tools. And that extension of models to the textual requirements also give amazing capabilities in terms of test automation, which I will present. In that talk, I'd like first to come back on the challenges practitioners are facing today, system engineers and testers. The challenges they face are extremely difficult, often ignored by their management, by many other persons. And it's important to realize how difficult the job they got to do is before I introduce then the solution that really is a game changer for these two categories of engineers. And eventually at the end, we can exchange on how this innovation can be introduced in your companies.
Correct.
I mentioned challenges. So at the beginning of the process, we said a bit earlier, you could have a model-based approach. Typically, the standard on these first phases, these first steps, is SysML. We have a great tool in Dassault Systèmes, CATIA Magic, former Cameo, that is providing a great support for these first phases. It's essential to rely on a tool to create a new system, master the complexity, investigate the functionalities to be provided, the use cases to be satisfied, and so that's important, very important. Beyond that, you will still, as I said earlier, write textual requirements to capture the details of the behavior in particular, of the various components of the architecture. And that's going to be plain text in a SysML model. Therefore, they resist to verification or simulation capabilities. And therefore, many errors can be there without being detected. And you'll see the traditional review doesn't cope with the complexity of the task. Then
Yves,
next step.
Yves, sorry, just interrupting you. I mean, when you're designing these highly complex products, I mean, what are you typically seeing is the error count, the percentage coming out of these functional requirement specs?
When we look to the precise set of requirements, which I will present a bit later, the percentage of these requirements on which we that we analyze with Stimulus that are eventually detected as faulty, wrong, it's always above 70%.
Wow.
It's a lot. It's a lot. And it means that almost every time you create that kind of requirement, you are increasing the technical depth of your company, and your colleagues later on are going to have real challenges to cope with these errors, fix them in the system, etc. So it's a very critical moment that, as of today in the industry, is, if I say out of control, that would be a bit too much, but it's a very, very, very hard time for the organization.
I mean, it doesn't surprise me. I mean, using natural language, I mean, you know, even when we text each other, we make mistakes and don't understand each other. Never mind when you get into systems engineering. I can only imagine the delays in design are just exponential. I mean, just huge.
Absolutely, it's a waste of effort and energy, and it's not necessary anymore. And that's what it's the good news of today, basically.
Yeah, getcha. Sorry, Yves, back to you.
Like
did we lose Yves?
We just lost him.
I think we lost him. Hopefully he can get back. So, I mean, Bryan, this is a tool I came across. It's been going around for a few years. I think it's been in the market since 2014, 2015. And, you know, we look at MBSE, we look at the amount of delays and the complexities of it. So, you know, welcome back, Yves. Sorry, I think we kicked you out there.
Indeed. I don't know. Did I say anything wrong?
No.
Yes. Yeah. Very upsetting.
Yes. We were so upset by the fact there are 70% mistakes that we just couldn't handle it anymore.
Yves, how long has Stimulus been around?
Oh, since 2015, actually.
It is 15.
So it's combat proven.
Yeah, exactly. You've earned your stripes. Got it. Back to
you. So with all these requirements, so an important proportion of which are wrong, contain errors, then the next step is the creation of test cases, because they are the test objectives, the functional requirements. So you're going to create test cases manually derived from a natural language piece of text. And that, again, is a challenge. It's complicated. It's not fun. And you can inject errors again. So, and you don't get enough test cases because it's just too costly activity. Then after implementation, when you're going to be testing the software, typically the control command part of a complex system, you're going to be willing to compare the implementation and the specification and the requirements, and you sort of inherit of all the problems that were created in the two phases. So the software in the loop test, it's not a great time as well in the development process. There is, again, a lot of disturbances that occur at that moment. Last point, when you have integrated the software and the hardware and you test on the hardware in the loop environment, it's even worse, because you have something running at, say, 20 milliseconds per cycle, and a lot of things are happening. You can't check much at runtime. So you get big files with tons of data inside that you try to analyze afterwards, verifying if some requirements have been violated or not. It's a nightmare. This is a very, very challenging moment. It's complicated. It's costly. The equipment is costly. It's very, very difficult. So the reason for that big proportion of erroneous requirements is explained here. Actually, when you have a process, you go classic top-down, starting with system-level requirements, subsystem, etc., that you could do within the CSML environment, such as CATIA Magic. The kind of sentences you write are reasonably abstract because the model, the elements you're working on, is pretty abstract as well. It is normal at the beginning of the process. And so there aren't, when you look to one of these sentences like here, in the middle, the subsystem requirement, there aren't many opportunities to inject mistakes there. So that's okay. Natural language is okay. When things get...
Sorry, Yves.
Yes.
Sorry, just to come in there. We've got a comment here from Sion Tan. he's made the comment. My personal experience is that stimulus is useful when there is a temporal logic involved. Would you agree?
It's even more, the stimulus is even more useful when there is a temporal logic, meaning that it's not only about when the inputs are like this, this output shall be set to that value, which is a kind of instantaneous requirement, if you will. They contain mistakes also, actually. But when things get even more complicated is when you say, right, when this condition on the inputs is true for 2 seconds, I'm going to have to send the alarm to this other component within half a second. And then you have a constraint linking these inputs and outputs that lasts 2.5 seconds. And then you have other requirements happening also simultaneously. Some are instantaneous ones, some have their round duration, and the human brain just won't understand what's going on. It's just not doable. And a tool for that can handle that level of complexity is really essential. So it's an excellent remark from our audience.
I hope I pronounced your name right, Sion. So thanks, Yves.
You're very welcome. And to some extent, and that is actually the funny thing is it's exactly the example which is on the bottom right here. When you have a pretty complex critical system to develop, you got to be more precise than what you see in the middle with the subsystem requirement. And so you're going to inject tons of details saying, I have this value for this signal, the signal name is this one, and that value must be this one for 2 seconds, etc. So you inject many, many details, which are as many occasions to make mistakes, and that is when things get really out of hand. It is in that kind of requirements that we're going to find many, many errors always, despite the fact that, again, it's not about the commitment, the education, the intelligence of the authors. It is just that behind a reasonably simple piece of text, you have so many running in parallel that the human brain is just unable to cope with that level of complexity. So asking system engineers to resolve the challenge with the manual review is just unrealistic.
Yeah.
And that's what you see here. You have these stats. So I was mentioning often more than 70% of the requirements contain errors, but you have also this other stat saying that 70% of the errors that are raised and detected along the development process, or even worse after, their source is in erroneous requirements. So it's a big issue that companies can address. So it's a big problem, and a very good news that now there is a solution for that problem.
Right. And Yves, I'm doing it again. I keep doing it. I know. Does stimulus only work with CATIA Magic? CATIA Magic, obviously, we're lovers of it. We enjoy working with it. But will it only overlay on CATIA Magic?
As we are Dassault System, we have created a connection with the CATIA Magic that enables to import the architecture that has been developed in CATIA Magic. And once you have imported the architecture, so block diagrams or a hierarchy of block diagrams in Stimulus with the signals that were defined in CATIA Magic, then we're going to do our magic, creating the detailed requirements in Stimulus, doing simulation, blah, blah, blah. If a company is not using CATIA Magic, but using another CSML tool, anyway, the level of abstraction in which we are working is practically absent of a CSML tool. So you could use something else, basically. The only thing is you're going to have to recreate manually the architecture in Stimulus. It's going to take you 3 hours. It's still worth it.
Yeah, you bet. Yeah, so that's nothing compared to design delays that are incurred. So Good.
Absolutely.
Okay. Thank you.
Absolutely.
All right.
So I show you another example of plain text requirement, natural language requirement. There's a lot of things here that could be open to interpretation, where you assume some knowledge from the reader that might be there or not. You give them to testers who are going to derive test cases, so sequence of inputs, unexpected value for an output. And often testers don't have the knowledge that the system engineer has. And so he's going to be really wondering what's the text mean, can make wrong interpretation, which means that the test cases they have created can be questionable as well. When you look to all when you look to all this, you would say, oh, what could go wrong? And a lot of things will actually go wrong.
Yeah.
In such a process. So to summarize, starting from natural language requirement for that category of requirements I mentioned, detailed, functional requirement for embedded systems to be application scope of stimulus. If you start with natural language requirement, then you're doomed, so to say. You're going to have to create your test cases manually. You'll have tons of errors that you're going to be dealing with when you do the validation. You won't have enough test cases. Errors will remain in the code. You're going to be struggling in the last phase with the hardware in the loop. I mean, it's really not fun to be a tester. It's difficult to be a system engineer. Being a tester in such an environment, it's very, very difficult, and that's an understatement. Believe me. You don't want to do that. Yeah. On that last phase, you got to imagine that when you are doing the hardware in the loop tests, as I said, you get data from the testing environment that will be analyzed later on. And what are these data? They are the inputs and outputs that were observed on the system on the test. And imagine you have that huge Excel file, hundreds of thousands of lines, and you give it to somebody and say, John, can you please tell me if any requirement has been violated? And you got hundreds and hundreds of sentences that can be complicated, ambiguous, that possibly contain mistakes. And you're supposed to do this verification? Not doable. It's actually not doable. So they're going to be focusing on very limited verifications, actually, and that would be difficult. Well, one thing, Andrew, you asked me about what kind of percentage of requirements are actually wrong when you work with clients, with stimulus, and I said, a lot. How is that possible? Because at the end, all these companies are professionals. They've been working hard and got products on the market that were decent, if not high quality products, and they work. So what is that contradiction? And actually, the reason is, even though the processes, you have guidelines in every company saying, if you find a problem in a requirement, you got to report it. So it's being corrected and put in the requirement management database with the correction. It's not what is happening, actually. Most of the problems are discovered during the development and the validation. The problems are fixed in the product, and they aren't fixed in the requirements themselves, because people are just too much in a hurry. And that is the only explanation why we find so many erroneous requirements, when actually eventually the product is a good one. But it's a good one. It has costed a huge effort that was not necessary, actually.
Yeah. No, it's really changing the game, isn't it? I got to say, I mean, just in simple terms, somebody's running a 400-meter race, and you're actually dropping them into a 100-meter race now, because you're allowing them to sprint much, much faster and to get it right first time.
That's right. today, nobody's questioning the fact that if you're going to do a 3D system or 3D thing, you're not going to do that with a pen of paper like I did when I was young. You're going to use a 3D modeling tool, CATIA, or something else.
Exactly.
So it's a fact today. And I give you a rendezvous in 10 years' time. It will be really obvious to everybody that a detailed functional requirement is, of course, written with a proper tool to be a digital artifact that leads to powerful verifications.
So it sounds like you're basically saying that we have, kind of what the wheel did for traveling is what we're showing here is how this is really going to be able to, as this is adopted, let companies figure out much better ways of doing the process of requirements management. Are you seeing clients you're talking to getting excited and adopting this and understanding it, or is it an uphill battle to convince people that they want to start going down this route?
Oh, it's still a battle, I must say, because many colleagues or clients who have adopted stimulus understand it. And they say, oh my God, why don't people see the value as soon as you read a couple of slides and see a video from Yves GÉNEVAUX? It's just so obvious that we save that amount of time. So actually the benefit, it's a very frustrating and exciting product. Frustrating because we feel that we have something extremely useful and pretty easy to use, which is very, very important. Delivering a lot of value, but though it's still a game changer, it's going to mean changes in companies, and that is not easy to deal with. Everybody is extremely busy with tons of things, and it's sometimes difficult to take the time to think a bit about the way you work and revisit that for adopting a better practice. So it's not easy still now, but the user community of Stimulus is growing now faster and faster.
Are there any additional problems related with design change requests? I mean, you kind of slightly skirted around that subject matter in a different way, but as you go forward and people are changing designs and bringing it back through, any added complications with Stimulus?
Recently, presentation that we made.
I think we might have lost
we just hold on, Yves. We just your connection's got to stabilize again. I think you're back.
Right. It's interesting that question about late changes, because actually, as you speak with system engineers, everybody complains because indeed they have late changes that they need to do in specs that were reasonably mature and ready. And when recently there was this work done in an automotive company, and what they were reporting to their management is when they have to do late changes in a specification, and then of course late changes in the code, and both because of the functionality I'm going to explain soon, the amount of effort was reduced by 90%, 90, which is just enormous.
Okay,
so
we are struggling in northern Italy right now, I think.
It's a good free frame, though.
Yeah, exactly. Yeah, we'll have to send him that one. Let's see if we can get Yves back. Give him a couple of minutes. Yves, are you back with us?
I'm with you.
Okay, let's go again. Let's let you move into CATIA Stimulus, the new paradigm.
Thank you. So what's the innovation, basically? It's the fact that you can capture these detailed functional requirements as part of the model with a digital artifact that the tool understands. The fact that you provide with structured English. You'll be able to say that.
Yeah, I think
we're having a problem here, aren't we?
I think the internet connection just went underwater, robotic-like.
Yeah,
Like.
yeah. I think everyone's going out for dinner and going online over in northern Italy. Good for them. Yves, I'm not sure. Let's give it one last try. Let's see if we can keep you with us. Yeah.
Sure. So what I was explaining is the fact that you write the requirement in a stimulus tool using a kind of structured English, which is understood by the tool. It's an executable language, gives extremely strong verification capabilities. And that is a game changer. On the kind of benefits you're going to get is, for instance, finding errors, of course, like conflicting requirements. When you run a simulation, you see the lines which show the evolution of various signals that you are interested in. The simulation could be stopped at a given point because stimulus found that there are two requirements which have a contradiction. They are active simultaneously. Therefore, there is no solution. And conflicting requirements are a real difficult challenge in embedded systems.
Are companies very surprised when they find that they have requirements that are conflicting?
I beg your pardon?
Do you find that clients are really surprised when when it's pointed out, oh, you have these conflicting requirements, and they're like, how did we have that?
Stimulus is a surprise generator. You have no idea. You write a few sentences, you think that, well, it's going to be all right. I feel that things are under control. Push the play button, boom. You get conflicts you didn't see coming. You get errors. You get strange behaviors because your requirements are wrong. It's actually a very funny tool to use because you're permanently challenged. When you look into the simulation, you realize, what? Why is the system behaving like that? And of course, the issue is what you wrote, indeed. So it's constant. It's a constant flow, and you write 3, 4, 5 requirements. You start simulating. It's going to take 3, 5 iterations of corrections at least until you get something that starts to work properly. Yeah. It's just normal process, actually. Another thing you're going to find is holes in the specification where you find missing requirements. Basically, there are moments where a signal, an output, can have an erratic behavior, and it shows that at that moment there is no constraint applied on that output, so no requirement defined what the system should do. Finding holes in the spec is, of course, really useful. And eventually, you find a lot of errors also where simply the requirement doesn't behave as you intended. In that example, you expect to put an output missile status to knock 2 seconds after the GPS has been down. And when you look to the curves, you see the green curve, the GPS becomes knocked permanently at a given point, but the blue line, which is the missile status, stays okay. So you don't get the behavior you intended because what you wrote, it contained mistakes. And that is really extremely common, actually. And having a tool to find these mistakes is a necessity, actually. How do we do these simulations? Actually, so the stimulus model is composed of architecture, possibly inherited from CATIA Magic or created in stimulus, and the description of the components is done using textual requirements captured in stimulus or also state machines. If you want to simulate and observe the response, classically, you create yourself a set of inputs and observe the response. But that, again, is a manual creation of test cases. You start to enumerate an endless number of different test cases, it doesn't work really. It's not effective enough. What we do from Stimulus is to have these test scenarios, see them as a set of constraints, defining a space within which all kind of combination of inputs can be generated by Stimulus and sent to the system. So it's another meaning for the simulation term, because it's a intensive simulation that can be done overnight. You're going to stress your model on a very, very powerful manner and come in the morning, and you're going to be only working on the simulations that raised some issues. Then you're going to have, you'll be able to hand over to the developers a proper set of requirements. The story I was saying about the 90% effort reduction because the late change was done on the stimulus model and not with plain text. The guys who developed actually a Simulink model for the implementation said it was the first time we got a spec that was correct and complete. The guy, they have 20 years experience developing embedded system. First time they see a spec that is correct and complete, because they reported to the top management of that automotive company. So how do you then verify that the implementation meets the spec? You reuse the same mechanism. You replace the spec with the code or a functional mockup unit generated from control build, Simulink, SCADE, whatever. And we're going to stimulate the code with the same stimuli than those generated to test the spec. And you put the spec into an observer. Any violation of any requirement for any execution and any cycle of this execution is detected automatically, is just, well, much better than the current practices. Immensely more effective. Immensely more effective.
Yep.
The last phase, as I said, it's very difficult because testers are facing these huge data with the inputs and outputs that were observed in the hardware in the loop environment. But if you got Stimulus, simply load this data into Stimulus. We can again observe the evolution of the inputs and outputs that actually occurred during the tests, compare with the specification that you have put into an observer. And again, any violation of any requirement is detected automatically. You could also, about that, and it has to do with quick wins and short ROI. If anybody who's listening to us today gets a Stimulus license, brings this huge hardware in the loop file that some of his colleagues are trying to analyze today, really painfully, tomorrow, we're going to just ask to one of my colleagues to write, say, one safety requirement. It's going to take 3 minutes to write the sentence in Stimulus, and then they will be able to analyze automatically that file and find possibly safety violations with very, very little efforts. So this feature here is amazing because it's an horribly complicated phase. And anybody getting a Stimulus license can get result the very first days, not because he would have created a huge, complex specification that he would have simulated to make sure it's correct. No, just forget it. Write one sentence and use it in an observer. You're going to get the results immediately. That is absolutely amazing. It could save a lot of effort. Tomorrow we are Wednesday, so tomorrow Thursday, a lot of people could benefit of that already.
Yeah. Yves, just about kind of generating test cases, manually doing that takes a long time. Give some idea how quickly does Stimulus turn around generate those test cases, and is there a limit to how many that are generated, etc.?
No, there's no limit. what you do, as I mentioned, is create a set of constraints on the inputs. You could say, for instance, when the speed of the car is over 40 kilometers, this other input, which is the speed regulator enabled, might be always yes or no or whatever. So using the language you saw on the requirements, you can define constraints on the inputs, and you are in given ranges. You can use state machines to define a sequence of events. And if what you've done is not deterministic, then you're going to ask stimulus, please make me 10,000 test vectors.
Yep.
Each of them being maybe 3,000 cycles or 10,000 cycles. So you can generate millions of points within a couple of minutes and use that to test automatically your spec overnight, to export them into another environment that you're going to use to feed the testing environment, etc., etc. It's a extremely powerful way to get out of the old syndrome of I have a requirement, I create one test case, oh no, two. Okay, I'm going to do three, but then I'm actually exhausted. I need to move to the next.
So something that's just been in the back of my mind, something that's been in the back of my mind throughout this conversation is return on investment. Mainly because in product lifecycle, we need to be talking about that a lot more often than we do. Have you looked at the ROI on this kind of tool, what it might look like? Because it feels pretty huge. Yes, we are going to address this point indeed in just in a couple of minutes, if I may. Sorry. Yep, sure. Just to basically to summarize, we are at the end of these presentations. CATIA Stimulus and CATIA Magic, used before CATIA Stimulus, together they make an incredible combination to control on a much more effective manner the whole development process from the very beginning to the final validation phase. It extends the use of models to the textual requirements and bring amazing test automation capabilities, which are absolutely new. I mean, everybody's got test automation, but it is the automatic repetition of the previous test campaign, nothing else. But the test cases are still created manually, one by one, when we speak about the functional aspects. And all this is possible, all these new services are possible because the basic artifact that is the source of all these activities, the detailed functional requirement, is a digital artifact. It is understood by a tool. And I'd like to stress that at the moment where you only hear about digitalization in every company, we are in a digitalization process. Who thinks about digitalizing that very crucial artifact, which is the functional requirements? It must be digital if digitalization must mean something. Yeah. Agreed. So indeed, question about ROI. Yeah, I could take. It's an embarrassing question. When you look to the cost of errors in each and every requirement, and that there are so many actually, and again, I tend to say that system engineers are the only engineers who are not allowed to get engineering tools. I mean, they have requirement management, but no engineering tool helping them to create an artifact, to challenge it, to test it, validate it, and then give it to the next guy in the chain. And that is really necessary for complex system. And it means that when we look to a set of requirements, as I said, we find a lot of issues.
meaning the benefits also come extremely fast. You have this example of a very safety critical function that needs to be developed. It's a couple of dozens of requirements. And keep in mind that even though systems are complex and there can be tens of thousands of requirements, they are a collection of objects that the number of requirements of which is small. It's a dozen, 15. More, everybody's lost. No one understands anything anymore. So you can always start picking a critical component. It's important to make it right. And it takes a couple of days to get it right only. And then you can move to the next, etc. So the return on investment with this kind of solution is extremely fast because it's a very favorable environment to get quick ROI, knowing that the requirements, they are supposed to be atomic. So virtually you could test and run one of them with no knowledge whatsoever about all the rest of the system or the environment. So it's a very easy, it's an easier environment to be able to do very quick, not dirty, quick and powerful applications on components ROI within a matter of a few days. So it's very, very important to catch.
Yep. I get it.
We see that.
So I was going to say, so I think you're moving on to it, and which is, how easy is this to adopt? Because we talk about MBSE adoption, and you've got the naive who think, put me on a training course and I can run an MBSE program, and here we go, and then realize they need mentoring and all sorts of things. But how easy is stimulus to introduce? I know you've got that initial training course. Is there more that needs to be added after that 3-day kickstart?
A bit of mentoring and coaching afterwards, but basically we get the systematic feedback that stimulus is one of the easiest tools people have met, is modeling engineering tool people have encountered to learn and master. The tool is great. One of the reasons is there is a lot of technology inside, making it apparently simple to use. Another reason, because we get to be honest,
I think we lost the last bit there. Yeah,
I think he's going underwater again, Yves. Yves, we'll wait for you to start moving, hopefully, and come back to us.
I guess
not quite. You're still a little phasey. Just one thing, Bryan, I did a little research on this, and I couldn't find any competition out there for it. I got to be honest. I don't know if there is anything. That's something I wanted to ask Yves. You then kind of say, well, why isn't there competition? Which I should imagine it's because, for 8 years they've been building this. So, Yves, are you back with us? Not quite. Maybe.
I'm back.
Okay, hopefully. I was going to ask you the question. Let's see if you're back. Not quite. You're still in that glass of water.
We really should look at the systems requirements for the internet connection from Italy and see if there's some clashes happening here.
Looks like Yves is back. Another quick question for you, Yves, which is, I looked around, I couldn't see any competition. Am I right? And if so, why not?
Yes. I hope you can hear me. There is no competition, no comparable tool on the market to stimulus, which is weird because there is a need for these kind of things, actually.
Yep.
There is a need for this kind of service.
Yep. So why not? How come?
Can you hear me again?
Yeah.
Yeah, can hear you. How come there's no competition?
And so there is no competition, even though the needs from the market are huge for this kind of solution.
Yeah.
Because in order to be able to do what we do, as you know, a tool that is simple to use probably means that there's a lot of technology inside that is hidden,
true.
and that's going to do a lot of services for the user that would even not notice these services. And that's exactly the case. In Stimulus, you got one of a very advanced constraint solver, an engine doing what is called abstract interpretation, which is a branch of the math and of the verification, which is extremely complicated as well, plus some other stuff. And you have to put together worldwide top researchers who are top worldwide experts in these domains to put them together, their skills, knowledge, and algorithms in order to be able to do what we do. And that explains that as of today, we don't see anything that, even though Stimulus has been on the market for 7 years, we don't see anything that is even trying to do what we do.
Impressive, impressive. Yves, fabulous tool. I can feel your passion for it, really can. Something we're starting to jump into now and getting excited about bringing to our customers. So thank you, sir. Much appreciated. I think we covered all the questions. We're going to look forward to seeing you in Göteborg in Sweden, which was also badly pronounced, but down in Gothenburg. See you there. Good luck with your speech over there. Thanks for joining us.
Thank you, Andrew and Bryan. Take care.
Yeah, thanks.
All righty, everyone. So we struggle a little bit with connection, but I think hopefully you saw that you've got a tool that is massively quick ROI, huge exponential speed up on design, potentially coming out of systems engineering. Fascinating to see, and apparently no competition. Let's go take a look at that. What do you think, Bryan?
Yeah, I think a fascinating point is the lack of competition after 7 years of making some serious changes, and the speed with which ROI was discovered. You know, that said, in some cases 2 days is really impressive. So I think it's fascinating, and I'm also just impressed with how the surprises of people who like, hey, I've put all this together and it seems to work, and then suddenly they say, wait, I've got 12, things that are contradictory here in my only 20 requirements and stuff like that. Is it proves that it takes a machine sometimes to really be able to do all the logic because of our human brains.
Exactly. You got it. All righty, everyone. Next week, we're jumping back to working in PLM 4.0. We are looking into the world of PLM business consulting. Fascinated. Got a lady joining us, fresh in from Dassault Systèmes, to look at what does it mean to look at business processes, what does it mean to look at the business, and how we can develop that return on investment, having implemented product lifecycle, best practices, etc., etc. So look forward to seeing you same time, same place next week. Hopefully she's not in Italy, in northern Italy, swimming. Hopefully she's somewhere with a better connection. Fingers crossed. Have a great week ahead, everyone. Thanks for joining us.
Thanks for joining us, everybody.